Hey guys, Mr. Taylor here with Rocket Math. Just want to talk to you briefly or give you some examples of three-dimensional figures. First one we want to talk about and give you definitions is on a cube. So it tells us that a cube is a three-dimensional figure with 6 square faces, 12 congruent edges, and of course 8 vertices. So what we have is we're looking at 6 faces, 1, 2, 3, 4, and your 2 bases, which is 6, 12 congruent edges, 1, 2, 3, 4, 5, 6, 7, 8, what did I miss? 9, 10, 11, 12. Okay. And 8 vertices. The 8 vertices is where your edges meet. 1, 2, 3, 4, 5, 6, 7, 8. And here's what the net look like. Opening up on the bottom, as you see, here's a side, and then of course a side, and the top folds over to close the box, so to speak. Rectangular prism, three-dimensional figure with 2 congruent rectangular bases. So that means a top and a bottom to the box. It has 4 rectangle lateral faces. 1, 2, 3, 4. Okay. And here's what the net look like. Okay. Let's take a look at a triangular prism. A triangular prism is a three-dimensional figure with 2 congruent triangular bases and 3 rectangular lateral faces. So here is 2 congruent triangular bases and 3 faces. So we're looking at 1, 2, 3, and then of course your 2 bases. And here's what it looks like. Okay, 1, 2, 3, 2 bases. Okay. So let's look at a Pentagon prism. Three-dimensional figure with 2 congruent Pentagon bases and 5 rectangular bases. Okay. Pentagon here, Pentagon here. And of course we have our 5 rectangular, 1, 2, 3, 4, 5. And here's what it looks like. This is the net. Okay. Please take your time and make sure you draw each of these figures. Have these figures somewhere where you can study. Okay. Let's take a look at a hexagon prism. So three-dimensional figure with 2 congruent hexagon bases. 1, 1. Looks like a hat box, doesn't it? And, well, maybe, yeah, looks like some type of hat box. And 6 rectangular laterals. So here are your 2 bases, the top and then the bottom, and then your 6. 1, 2, 3, 4, 5, 6. And that's what it looks like as a net. Okay, octagon prism. It's a three-dimensional figure with 2 congruent octagon bases and 8 rectangular lateral faces. So here, octagon, octagon. What's this little thing where I see that people put, what, not those little mice, whatever those little things that looks like that, and also look like a bingo container. But anyway, the net goes here, here, and then got to be away from me now. Yeah. There's a base, and then your 8, 1, 2, 3, 4, 5, 6, 7, 8 rectangular faces. And what's next? Triangular, and this is a pyramid. So we have a three-dimensional figure with one triangular base and three triangular faces. Triangular base creates this pyramid, and I know make sure you want, because we got something coming up next that's a little different. This is a pyramid and one's a rectangular pyramid, but the difference between the two is the base. As you can see, triangular pyramid is a three-dimensional figure with a triangular base and three faces. 1, 2, 3 faces. Pretty easy to identify here. Let's look at the rectangular, which I say is a little bit different. Actually, let's go ahead and compare these while we have them. So you have a triangular prism and a rectangular prism. We could see that with the rectangular prism, it's a three-dimensional with one rectangular base and four, right? Triangular lateral faces. So the difference between the two, one has 3, the base is different, but they both sort of open up as a star or something. Okay. 3. So we have this Pentagon pyramid. It's again, we're looking at a three-dimensional figure with one pentagon base and 5 triangular lateral faces. So here's our pentagon base, and then 1, 2, 3, 4, 5. Something that I might want to point out to you. Notice this little thing that's going here. This is the height. There's our right triangle, and these are our lateral. The lateral height. These we'll use all of these when we get to finding the surface area, and again, here's our net and what that net looks like. All right, hexagon. It's a three-dimensional figure with one hexagon base and 6 triangular lateral faces. So again, we have this height compared to these laterals and our right triangle here. So how many? 1 hexagon base and 6 triangular lateral faces. So we have 1, 2, 3, 4, 5, 6. Okay, and then that's what our net looks like. This is good study material for you guys. Really good study material. And then we'll move it on up to the last 3. And one is an octagon. Again, it's a three-dimensional pyramid. Actually, let's make sure we put the pyramid in there. It's a three-dimensional figure with 1 octagon base and 8 triangular lateral faces. So here's what it looks like. Again, you see that height, and these are lateral heights. Tents are made like that. TPs. Okay, and so anyway, yeah. Here is our octagon figure, and then our 8 triangular sides. Okay. Cylinder. We'll be using a lot of these. It's a three-dimensional figure with 2 circular bases and no vertices, and a curved lateral surface. No vertices. So what that looks like, when we open up this curved lateral surface, it looks like a rectangle, and then we have 2 actual circles. Okay, these are the bases. Cone. It's a three-dimensional figure with 1 circular base, 1 vertex, and a curved lateral surface. And then when we open this up, it looks more or less like maybe triangles or a half circle, something like a baseball diamond. Wouldn't you agree? Except it has a half circle on the top and then one circular base. All right, looks good. Again, it would be really to your benefit to take your time and copy and put these in your notebook and bring to class as we discuss and create these nets for our upcoming test and review.